All right, folks. Welcome back to the second live stream of the day, the one I wasn't planning on doing, a pop-up version of the Weather West live weather and climate office hours. That's the live part, I guess, that gets you sometimes when the weather does something interesting, or in this case, both interesting and somewhat unexpected. I try and be here. And walk some folks through it. So what we've got is an outbreak of quite widespread thunderstorms throughout Southern California, including the highly populated coastal plains. So certainly the Inland Empire, but now also the LA Basin, and now imminently Orange County too, and perhaps other areas at this point. It kind of looks like all of Southern California is going to get in on the action in the next hour or so if you haven't already. So as always, during these live pop-ups, it's especially helpful for folks who appreciate the content to like the channel, because this is, for better or for worse, seems to be how the Weather West channel expands, is with these pop-up sessions concurrent with active weather live in real time, and that's exactly what we've got today. So thanks for sharing, liking the channel, all that fun stuff. So I suspect most of you probably don't want to see me, my face on screen talking. What I'd really like to do with today's session is show some radar and some satellite imagery. And so that is what I'm going to do now. So bear with me as I share my screen. You'll see the infinite mirror. The first thing I actually want to bring up is the radar. So let me just double check that's actually what you're seeing. Sorry, I have to check it and then verify it. We'll go back to it. Okay, that's good. All right, I'm going to take a sip of tea here since I've been talking continuously for the last 6 hours. Just give me a second here. Okay, this is live weather radar from the LA area. This is just about the most thunderstormy map I have seen in a long time in Southern California. Nothing else to say other than widespread thunderstorms across this entire region, extending all the way from the offshore waters between Catalina Island and Long Beach. There's storms offshore. There's storms over LA. There's storms in the Inland Empire. There's storms in the San Fernando Valley. There's storms in the San Bernardino Mountains. There's storms out in the desert. There's storms to the south and east. There's thunderstorms everywhere. And you can kind of see, let me see if I can get an extended loop here. Let's see here. I want to have a longer loop. I believe that's in the settings here. Let me just quickly, here we go. Let's go 36 frames. Why not? Here we go. So this is going back a couple of hours. You can see the whole round of these storms develop across Southern California. Really, they began over the mountains and deserts earlier in the afternoon, but then they really blew up when they came over the San Bernardino mountains and the mountains in eastern and northern LA County. But unlike what usually happens in these scenarios, these storms did not blow up over the mountains, and then kind of die off as they came into the valley. But instead, they've maintained their intensity in this region across LA Basin, Inland Empire, and now all the way to the coast. Obviously, that means the atmosphere is maybe a bit more unstable than had been foreseen, although there were at least isolated thunderstorms in the forecast today from your favorite local National Weather Service office for even the coastal areas. So this was not out of nowhere. It was in the official forecast that there was at least a slight chance this would happen. Well, this is one of those slight chances coming to fruition in a pretty big way. So a few things to point out here is that a lot of these storms have developed, we could call them in situ. So look at the storms here. They didn't come from somewhere else. They just popped up as if out of the ether. They're not truly out of the ether, but they are, it is fair to call them pop-up thunderstorms. So what you can kind of see happened here is there was some sort of boundary here. Perhaps, I don't know exactly what it might be. Satellite might tell us more. But as this boundary, it may have sent some outflow winds in this direction, and then perhaps even a bit of a sea breeze convergence at the surface. I don't know exactly, but there's some sort of boundary here, maybe a convergence line. There's just too many storms popping up all at once in the same region. So I think that's probably what's going on here. We have prevailing southeasterly flow at upper levels due to that upper level low. This is the favorable quadrant. If I zoom out, the low is let me draw it offshore. The low is somewhere offshore. We have flow that's like this on average around the low. This general quadrant of the low pressure system is going to be favorable for upward vertical motion in the atmosphere, the development of clouds, the development of potential storms if there's enough instability and moisture around, which there certainly appear to be. And in this case, it was just enough to trigger the storms over more than just the mountains and deserts. So as you can see, earlier there was a pretty hefty cell right over 29 Palms area, leading to some pretty significant flash flooding. It kind of just sat there for a while, so there's significant flooding out on the roadways there. Also, a flash flood warning now in effect for portions of the San Bernardino Mountains and the Inland Empire, so Ontario, Riverside, San Bernardino areas, including parts of Redlands. It's partly because of the burn areas in the mountains above the valley, but also I think this warning is for the valley itself because there's been pretty heavy rain that can cause roadway and street flooding and some localized flash flooding elsewhere. The good news is these storms, they aren't super persistent. So even though you could foresee there could be a potential for training because they're all kind of moving over the same area, they're not really sticking around for so long. You can kind of see that the most active area was first up here, then it was down here. It's sort of propagating in this direction towards the coast. So they're not sticking around for any one period in any one place all that long. There are some pretty heavy downpours associated with it, and there has been some flash flooding again in this region and then in this region, and who knows, there could be potentially elsewhere, any of the recent burn areas. But this rain, I know there's a lot of oranges and reds on the map, but they're very transient. They aren't sticking around. A lot of people are reporting some brief bursts of large droplet downpours, some rumbles of thunder, and then the storm is moving on. So this is clearly a widespread thunderstorm outbreak, but there will be widespread measurable precipitation in the LA area, Orange County region, but it probably won't be very heavy except in very localized places. In fact, there is a risk of wildfire ignitions. There will probably be at least a couple of wildfire starts because although there is some rain falling, it's not a whole lot in a lot of areas. So there could be some wildfire starts from this today. So I'm going to go back, take a look at satellite imagery now. This is what the low looks like from space. So I'm going to get rid of this. This is from my last live stream. We have a low pressure system somewhere over here. I'm going to try and leave that on the map. We have southeasterly flow like this, and the unstable quadrant of this low pressure system is sort of in this region, north and east of the low, and that's where all these thunderstorms are popping up. So you see this line offshore between the Channel Islands. You see the line that was originally over the mountains into the deserts that has propagated toward the coast, and now and it's now moving southward actually. So some complex motions. The individual storms themselves are moving in this direction, so northwestward, from southeast to northwest. But the boundary from these storms is actually moving southward. So the storms are self-propagating themselves in a different direction than the winds are blowing them. So again, the winds aloft, the steering winds are going like this, but the winds at the surface and the propagation of these storms is kind of moving in this direction. So there's this southward propagating boundary. These storms, even though they're moving to the northwest, will continue to build, it looks like, in the direction of Orange County, maybe even San Diego County later. I don't know how far west they'll make it, but there's some possibility of some isolated storms into maybe Santa Barbara County, probably not west of there. But this evening, the rest of this evening, I would expect to see some significant thunderstorm activity, uh, really throughout Southern California, really everywhere where all the population centers are. This is a high impact evening. It's right around the evening commute. It's going to be messy with widespread thunderstorms. I'm actually going to check the watch duty map, see if there's any fires. Looks like there might have been one reported so far, but that's now knocked down. So I'll check on that again in a minute. But I'll quick check the. I'm going to bring my face back up on camera briefly so that you see, so I can check on the comments questions. But then I'll go back. Just give me a moment here. All right. Let's see here. So I'm checking out the comments. Yeah, Anthony asks where I currently am located. I'm in Boulder, so I'm not experiencing the thunderstorms in LA at the moment. Eric comments, it's very rare for storms to form in the basin, not coming off from the mountains. It's certainly less common, although this is the kind of pattern. There are some outflow boundaries, and so they may still be related to the storms in the mountains, but usually the valleys aren't unstable enough to support that kind of activity once they do roll off the mountains. So it certainly isn't common. I'm actually trying to pull up while I'm speaking I need to log into my Pivotal Weather account. So this is another commercial weather provider that I'm going to try and share with you on air, since what I'd really like to show are some atmospheric profiles. Let's see here. I do not want that. I want this. I just think it's interesting to be able to illustrate sort of what's going on right now. Let's see here. Interesting. Very interesting. All right. That is right around 3, 4. That's right around now. Getting what we need for this imagery. Okay, it's 4 p.m. That looks about right. Okay, so a lot of folks saying that they're seeing lightning and rain, which is exactly what we would expect here. There's quite a bit of activity out there. Yeah, Orange County popping off. That's for sure. I'm to be quite honest with you, there's some folks asking what the numbers in the chat mean. I do not know. I think it has something to do with the level of activity in the chat. I'm gonna have to take a look at the YouTube user manual in a minute. If anybody knows, let me know. Yeah, as Jeff points out, this is something that the Weather Service forecast did quite well in the forecast discussion. It was, to be quite honest, something that I was not paying as much attention to because it's been a very full week, month, year, life, etc. Recently. But the Weather Service, whose job it is to do this sort of thing, they were on top of it, and they essentially, you could say, they nailed it. I'm going to bring the radar back up since I know that's what people really want to see. All right, I'll keep talking, but I'll talk over the radar. So again, this is a long radar loop going back a couple hours. You can see the progression of these storms from the mountains to the valleys and now beyond to the coast. Orange County. It looks like actually Orange County may be getting the brunt of it at this point. So there's additional lightning, by the way, beyond what is showing up here in this imagery. These are just the cloud to ground or cloud to water strikes. So anything that's cloud to cloud or which is probably a majority of the strikes. So this intra-cloud lightning, that's not even going to show up here. So you're probably hearing a lot more thunder than this map is showing. There's usually a lot more in-cloud strikes than there are cloud to ground, but there's still plenty of those. If we zoom in on Orange County, man, that's just a very active map. You can see all those radar returns, and some of them are getting pretty sporty. I'm gonna reduce the length of the frames again because I think it's getting a little bit long. I can bring it back later, but I'm gonna go back to 14 frames for the moment, just to keep things a little bit spiffier and speedier. Yeah, so you can see there's quite a lot of lightning right now. Huntington Beach, Newport Beach, all right along the coast, and also some of these storms are getting some really strong reflectivity. I mean, these are quite strong storms off the coast of Orange County. Look at some of those. That's like 70 decibels. That's quite an impressive number. Also, some good ones, Temescal Valley area, and then even out east. Beaumont, Banning. Quite a little episode of storms. This is somewhat more widespread than was in the explicit forecast for today, so I'm not going to argue otherwise. But again, there was a chance of thunderstorms in the forecast for coastal areas, and sometimes it's conditional. Sometimes 20-30% chance of showers and thunderstorms. It doesn't really mean that they're likely to be inconsequential. It just means that there's only a 20-30% chance that the ingredients are going to come together. But if they do, they could be a pretty big deal. And this ended up being more on the big deal side of things, I think it's fair to say. So the strongest storms at this point definitely sort of between south central LA and Orange County coast, sort of down in this region from Long Beach down to Newport. Pretty impressive stuff, but there is still this line, the back building, again, the Temescal Valley and the Inland Empire to the east. There is still a flash flood warning for a good chunk of the Inland Empire, and then also for out by 29 Palms, Joshua Tree area, so it may not be too many people watching from over there, but I would not be surprised to see these storms become more widespread, especially in this area down the coast. So the storms north of about here are likely mostly done at this point. So from about the northern LA suburbs northward, this area is likely to sort of peter out. Where we might see some strengthening is sort of in these circled regions here. We've already seen the strengthening in this region here in the last few radar frames, so these are some pretty impressive storms. So I'll check out watch duty again, see if there's any. No, not seeing any new fires. This is the current weather model for Southern California. This is the HER. Shown on the map, this is a forecast from a few hours ago for present time. Well, this is 3 p.m. Pacific, so I'll advance it forward. Here's 4 p.m., which is closer. That's within 20 minutes of the present. Let's see. Let's look at the 4 p.m. I'll take a sounding. So you can see the units here are in joules per kilogram. This is the CAPE, the convective available potential energy. Once you start getting above about units of 1,000, it's pretty juicy. Those are pretty high numbers. You can see out in the southeastern deserts there were some pockets of 1,000 to 2,000 CAPE, even locally a little bit more. That's pretty high. Also, over the mountains of Southern California, not quite as impressive, but some pockets up around 1,000 joules per kilogram in this area, as well as in the southern Sierra. But if we take a vertical profile, here's a model simulated profile of the vertical component of the atmosphere. This is not weather. This is not severe weather territory, so tornadoes, giant hail, unlikely to happen in an environment like this because there's not really a whole lot of wind shear. These are thunderstorms that are popping up because the atmosphere is unstable but not particularly sheared. Locally, your mileage could vary, but generally speaking, this is a fairly humid air mass by Southern California standards. So you have a dew point into the 50s and temperatures in the 70s with a fairly steep lapse rate and some upper level support. These are not particularly impressive convective parameters, I'll be honest, and that is one reason why I think the forecast didn't call for more widespread storms, although there was a chance. And that's sort of where we are. It ended up not being. It ended up coming out on the higher end of expectations, if you will. So I'll close this and look at a couple other parameters. Was there anything else that told us about severe weather potential? Well, was the model predicting thunderstorms for this explicitly if we look at the simulated radar reflectivity? Well, there it is at 3 p.m., the model prediction for storms over the mountains. That was pretty much correct with a couple of intense ones out over the deserts. That too was correct. Showing some progression into the Inland Empire by 4, and then I guess across a good chunk of the LA Basin, although by, what time is this? 5 p.m., so coming up in the next half an hour. Showing, again, pretty active storms across Orange County. So this particular model thought that storms would make it not quite as close to the coast as they did, but closer to the coast than usual. So again, it's outperforming a little bit, and that's sometimes possible. Here, I guess you do see pretty significant storms, orange down and starting into San Diego County later this evening. So I do think it's pretty likely that the rest of OC and San Diego County will see some storms this evening. Pretty good thunderstorm. So that's interesting what the model did and didn't represent. They did a pretty good job. They did not fully capture this. This is one of those, I hesitate to call it surprise outbreaks because it's exactly, 20-30% chance in the forecast. I mean, sometimes those 20 or 30% chances come to fruition, and this is one of those times. So I think what I'm going to do is actually start sharing only my radar, and then you will be able to see the radar while I can view the comments. Yep, this is what I wanted. So now you're getting the full screen radar, Southern California. This is live. It's going to be updating as I speak and take a sip. So again, Orange County right now, really being the epicenter of the current most active lightning for the moment anyway. Yeah, so I might switch to the Orange County radar. That's the KSOX radar. The only problem with that is that it's close enough to the mountains. The beam is blocked, so I can take a look at it. So you get a closer look of what's happening in Orange County, but you miss everything that's happening to the east. So this is not magic, but that you see that angle where there's actually nice big thunderstorms in this region, but the radar. Again, the radar site is right here. Oh, there's my drawing tool. The radar site is right here. The beam is blocked by the mountains here, and so you can't see east. So I actually think that in some ways we're getting a better view from the LA radar right now. Even though it's farther away, it's not as blocked by the mountains. There you go. So as you can see, the storms are rapidly fading in intensity south of this line. This flash flood warning will probably be allowed to expire, as will this one pretty soon. But this wave of storms is now really sort of focusing on this region here, moving forward. Yeah, not a good day to be out on the beach. Some of these strikes are literally striking, like for example, this one. Look at that lightning strike. Technically cloud to water, but just off of, between Seal Beach and Huntington Beach, that was probably a couple of boat lengths into the ocean. Some of these strikes in the coastal hills, inland, and then a bunch in this core right off of Newport Beach. lot of activity over the Channel Islands earlier as well. Fair bit of lightning up in this vicinity too that potentially could have sparked a fire or two as well. A new severe thunderstorm warning for the desert between Barstow and 29 Palms. Probably not too many people in this warning. It's not even encompassing any of the major highways, but if you are out there, it's probably quite the show. It's interesting. It's interesting to uh, reflect a little bit on the fact that the this is exactly the kind of weather that other parts of the country and the world see more often than Southern California. So we call it convective weather. Essentially, deep, moist convection is the scientific term to refer to tall cumulus and cumulonimbus clouds that produce heavy downpours and lightning. And it is relatively uncommon in California, generally speaking, simply because we often don't have a lot of atmospheric instability. So partly because we live at the margin of the stable subtropics, we have a lot of downward motion, net downward motion in the atmosphere, but also because we live near a relatively cold ocean. Colder in Northern California than in Southern California, but even in Southern California, cold compared to equivalent oceans at equivalent latitudes, even on the east coast of the U.S., for example, much colder. And so what that means is that although the boundary layer, the lowest level of the atmosphere, might be pretty moist, you get marine layer, fog, you can't argue there's no moisture there. There's plenty of moisture, but that's in a very thin layer. So the fog really only exists, sometimes the fog can be, the marine layer can be as thin as a few 100 feet deep. So literally something that a skyscraper in downtown LA or San Francisco is going to poke out over. More commonly in like the 1 to 3,000 foot range, which is tall enough to generate some decent stratus clouds, maybe even some coastal drizzle. But in the cloud kingdom, 2,000 feet ain't nothing compared to a severe thunderstorm reaching, say, 50, 60, 65,000 feet into the atmosphere. So the marine layer in California really traps a lot of that moisture in a very thin layer. So it's very moist, but it's only moist in that very narrow layer of the atmosphere near the surface. So once you get up into the 10, 20, 30,000 foot range, those altitudes where thunderstorms are most common, there's really actually very little moisture available for convective storms, for thunderstorms to develop. But that's not even really the primary limitation. The even more fundamental limitation beyond the moisture, which is often surmountable, and by the way, that's true today. There isn't an insane amount of moisture in Southern California today. There's just enough. But what we do have is instability. We have an atmosphere where if you give a bubble of air near the surface a little kick, a little nudge, if it encounters a mountain slope or a boundary, a gust of wind, it's going to spontaneously rise further. And it's going to keep rising and rising into the atmosphere. Those bubbles, those parcels of air are, as we call them, conditionally unstable. They're not absolutely unstable. They aren't going to start rising by themselves. But if there's just some random perturbation that gives them a decent little kick in the upward direction, they're going to keep rising. They're not going to fall back to the surface, but they're going to have what's known as a positive feedback. And so those parcels are going to keep rising and rising and rising until they cool. They condense, they form a cloud, and if they're tall enough when that happens, they form thunderstorms, and that's exactly what we're seeing today in Southern California, fairly dramatically illustrated on this map. And it's that lack of atmospheric instability that's the more common precluding factor for Southern California thunderstorms, or California thunderstorms generally. In fact, the California coast sees fewer thunderstorms than almost anywhere else on Earth, except perhaps for the high Arctic and deep Antarctic and places like the Atacama Desert or the Sahara Desert. And in fact, there are even places in the Sahara Desert, some of the driest places on Earth, that see more thunderstorms than does coastal California. And it's not because coastal California is the driest place on Earth by any means, but it is in fact often the least unstable, atmosphere-wise anyway. So that's sort of the lowdown on why this doesn't happen more often. Now, why is it happening today? As I mentioned, we have that low pressure system, which gives the atmosphere, it's both adding a little bit of extra moisture on the eastern flank, but more importantly, adding both instability due to the cooler air aloft. So it's not cold at the surface, but it's pretty cold aloft. So near average temperatures at ground level, but much colder than average temperatures aloft means that the lapse rate, the rate at which temperatures decline with height, is steeper than usual. That contributes to an unstable atmosphere. There's a bit of extra moisture from a former tropical storm in the Pacific that got entrained, not a whole lot, but a little bit into the flow, the southeastern flow around this low. But the more important bit is that atmospheric instability. The atmosphere is positively buoyant, given a little kick, and it looks like something gave it the kick that it needed. If these thunderstorms were occurring later in summer, there would be greater concern regarding fire weather and fire ignitions. It's not impossible. In fact, I suspect there will be at least a handful of new fire ignitions. But winds are not high right now. We're not experiencing an extreme heat wave, and it's still relatively early in the season. So there could be some grass and brush fires. They are unlikely to become fast-moving, dangerous blazes. So that's the generally good news for the moment. Also, there is some precipitation associated with these storms, locally heavy downpours, even if it's not widespread heavy rainfall by any means. So, as a couple of folks have mentioned, I think the numbers that you're seeing in the live chat represent some sort of YouTube leaderboard to encourage more activity in the live chat, which I'm okay with that. But don't let it motivate you to post off-topic content, since that's still a good way to have your chat privileges revoked. Mighty Mia asks, we rarely get thunderstorms in the Bay Area. Are they more common in SoCal, or is this somewhat unusual? They are a little bit more common just generally across Southern California overall than the Bay Area, although they are, it varies a lot depending on which part of Southern California. There are some parts of Southern California where thunderstorms are relatively common comparatively, so the mountains and deserts. You have very tall mountains in much closer proximity to the coast in Southern California than you do in Northern California. That's why it's far more common to see snow on the mountains surrounding Los Angeles than it is to see snow on the mountains surrounding San Francisco's, because the mountains are at least twice as tall and in some cases even taller. Those mountains are a catalyst for spring and summer thunderstorms more often than in Northern California by virtue of their height and suddenness. But also, Southern California tends to be a little bit closer to warm, moist air masses, just in general. It's a more southerly location, so occasionally it can be subject to moisture plumes, a little more unstable air. So the San Francisco Bay Area is probably the part of California that sees the least thunderstorms in general of anywhere in the state. Because further to the north, you get more wintertime atmospheric instability. Further to the south, you get more warm season instability. And in the middle, you kind of miss out on both. So I'll just take a quick look at the radar myself again before I continue to answer questions. Again, right now, most of the action is in Orange County. And there's quite a bit of lightning right now between Laguna Niguel and Long Beach. So, long since time to get off the beaches, off the trails, and hopefully the evening commute on the highways is not too much of a mess. Right now, thunderstorms over LA have now mostly decreased to just light to moderate showers. So I'm seeing the lightning is now largely done with north of central LA. But south, it's very active still. And this is going to, as I mentioned earlier, This whole region is likely to continue to backbuild. So for the remainder of the evening, I think lightning is quite possible in this entire region, probably including the Channel Islands too. Probably less so north and west. Question from Exodor. Would this be considered a monsoon like they see in Arizona? So there's a lot of use and abuse of the word monsoon. Monsoon actually refers to a seasonal reversal in wind patterns. So no individual storm can be a monsoon. A seasonal reversal of a wind pattern is by definition a monsoon. The Indian monsoon is a seasonal reversal of winds on the Indian subcontinent, for example, that brings weeks or months of highly stormy wet weather compared to the dry season. The North American monsoon, the one that affects Arizona and the southeastern deserts of California and the rest of the Southwest, that too is a seasonal reversal of the winds. In fact, it's actually when winds blow from southeast to northwest. So the moist air in this case is coming from the deserts of Mexico. How can that possibly be? Well, the deserts of Mexico are immediately adjacent to some very warm oceans. The Gulf of California, the Gulf of Mexico, and even the Pacific Ocean south of Baja California. They're much warmer and they make for a huge moisture source. So that is actually where the moisture is coming from. That moisture is coming from warmer oceans. They have to traverse a desert before they get to the southwest. But the amount of moisture that makes it to the southwest ends up being higher, even with that air coming from even more desert regions, because it's ultimately originating near very warm oceans. It just goes to show you how important warm oceans are. They can even overcome proximity to desert air. Andy asks, how many of these water drops originated south of here, and how much is native moisture, quote unquote, being subjected to rain-making conditions, or essentially how much of it is local versus being transported from somewhere else? This is actually an interesting scientific question. It's been answered in the context of atmospheric river storms, which are a bit different. But generally speaking, most of the rain that falls out of the sky in any given location at any given time is mostly water that was already in the air locally, within a couple 100-mile radius, or even less. So long-range moisture transport, it does matter. So every once in a while you see a big storm where 20 or 30% of the moisture has actually been moved from, say, Hawaii to California, where the actual individual water molecules have stayed in the air mass. But precipitation is actually one half of an equilibrium response with evaporation. So there's constantly precipitation and evaporation occurring, right? And in general, across long enough periods of time and space, they're going to mostly balance out. So what goes up must come down, literally. Not always in the same place. Sometimes what goes up in one place comes down somewhere else. In fact, that's often the case. But usually what goes up comes down somewhere relatively nearby. And the reason for this one net effect of this is that you often end up seeing, in an atmospheric river, for example, there are a handful of water molecules that actually make it from Hawaii to California. But the vast majority of them are water molecules that are evaporating from the Pacific Ocean, somewhere between Hawaii and California, and entering the moisture flow stream, because a lot of the ones that were there from Hawaii already rained out somewhere over the Pacific Ocean. They re-enter the ocean water supply, and then some new molecules evaporate out of the ocean, and those are what make it to California. So it's kind of a flux and flow problem. You can calculate the rate at which those individual molecules remain or fall out of the atmosphere. In fact, there's some interesting tracer studies using isotopes of carbon, for example, and oxygen that have been done to sort of follow the fate of individual water masses through the air. But anyway, most of this water is probably water that was already in the air above your head in Southern California. But it wasn't going to be squeezed out as precipitation, but for the unusual set of conditions we have today. So the moisture, not so rare. Unstable atmosphere, upward moving air currents, that's what's unusual. So I'm going to take a quick look at a couple other things just to see if there's any updates of note that I need to be aware of. I'm not seeing any more fire reports, so there might be just enough rain, but it's also possible there'll be some holdover fires that pop up in the mountains, so things that smolder kind of undetected for a while and then pop up once things dry out a little bit. That's always a possibility, but right now not really seeing a great deal of evidence of that yet. Let's see here. Just kind of checking in to see whether folks are reporting anything particularly dramatic on the social media channels here. Yeah, definitely one of the more active weather days in a long time in Southern California. It's pretty impressive. And, well, actually, that brings me to something I didn't quite complete one of my thoughts from earlier, which is that thunderstorms are more common elsewhere in the country and the world than California. This is one reason, by the way, why a lot of folks say, meteorologists, they don't know what they're doing. Weather forecasters, they're wrong almost all the time. Because there's going to be a lot of people in Southern California who say today, this wasn't in the forecast, this came out of nowhere, whereas it really was in the forecast, but there was a misinterpretation for a lot of folks what that forecast meant. Some parts of Southern California, there was a 20% chance of thunderstorms in the official forecast today. This is not inconsistent with that forecast. It just means that, 4 times out of 5, this pattern wouldn't have resulted in a widespread thunderstorm outbreak, but 1 out of 5 times, those aren't bad odds. Give me a lottery ticket with 1 in 5 odds, right? You're gonna get something out of it, and today was one of those days that it happened. This is why a lot of people think weather forecasts are so bad. Slight chance of showers, slight chance of thunderstorms in places where these are more common. People read slight as essentially 0. But slight, in this context, 20%, 1 in 5. So if there are 5 days in a given year where there's a slight chance of thunderstorms, it's very likely that at least on one of those days, you're going to get a thunderstorm. So it's important to understand the terminology behind the meteorology, because it's ultimately one of these things that really does play into the broader conversations that we're having about the value of weather prediction and people's understanding of how weather prediction works or doesn't work. To be fully clear, I do think that today's thunderstorms are more widespread than had been the most likely outcome, but they were not precluded by the official forecast that we had today, and there were some signs, there were a couple of models that were showing more widespread storms over the LA basin today, and turns out that's what happened. But in general, convective weather is difficult to predict, and you kind of have seen this, or it's more difficult to predict anyway than an atmospheric river. And I'm looking at the radar screen again. Just look at this area over Orange County. The thunderstorms currently roaring through Orange County, they didn't come from somewhere else. They just popped up in place. So there were thunderstorms up here previously, but these storms did not actually move into Orange County. There was a progressive wave of storms that developed farther and farther south. And they may have been influenced by the storms to the north. There might have been an outflow boundary or two that helped trigger them. Convergence boundary, maybe there was some outflow boundary from here and some sea breeze from here, and they converged in the middle somewhere along here. Sea breeze front, something like that. But ultimately, these were an emergent phenomena. These popped up seemingly out of nowhere. And that makes it a little bit more difficult to predict, because instead of having a feature that you're tracking, say if there were, and I'm just going to zoom out, I'm just going to use this drawing tool for illustrative purposes. If there were, like a more traditional cold front or something like this, you got a cold front, it's moving through, there's some rain along the cold frontal band, it's going to sweep through, right? It's going to go from west to east, Southern California, Santa Barbara gets hit first, then Oxnard, then LA, then San Diego. That's sort of the rigmarole that we're used to. Or even with something like that's unusual but discrete, DISCRETE, as in singular. For example, remember when Tropical Storm Hillary came up and kind of did this beeline like this? Well, that was really well predicted too, because again, it was a particular feature. It moved from point A to point B. It kind of did that over Southern California. But when it comes to thunderstorms, this cluster of storms, for example, it isn't really moving from point A to point B, like coming from here and going here. That's not what's happening. In fact, the most dramatic illustration, just look specifically in this circle. Where did this storm come from? Nowhere. It just popped up essentially in place. Same down here. Where is that storm coming from? Nowhere. It's just popping up in situ. So we often cannot predict individual thunderstorm cells. We don't really have models generally that are saying, okay, this cell is going to pop up specifically between Catalina Island and Long Beach at 4:45 p.m. It might say that there could be storms in this general region with some potential likelihood, and it might show some other distribution than we currently have in this area. But that's very different from a cold front or an atmospheric river. The weather model will say, okay, here's an actual cold front. There's a rain band associated with the cold front, and it's going to move across Southern California translationally. This is also, by the way, one of the reasons why machine learning methods, the image processing methods, don't work for all types of weather. They work great for types of weather where you're saying, okay, here's a front and it's moving from point A to point B at a particular rate and intensity. Because you can kind of just propagate it. You can predict if it's moving at 12 miles an hour. Well, just do the math. That's a high school algebra problem. How long does it take to get from point A to point B? But if the individual storm elements are popping up out of nowhere, you have to be able to predict something out of nowhere. And that's an entirely different prediction problem, whether you're using process-based physical models, whether you're using machine learning or AI-based models. As it turns out, the AI models are really, really bad at predicting these sorts of things. In fact, they are much worse than our traditional process-based models, which at least give us a better indication of when these sorts of events are likely to occur. So that's a bit of a frontier right now, and it's a place where a lot of these AI models started out being really good at moving things that already existed from point A to point B, but not developing new things. That is changing. The most recent version of AI weather models now do sometimes develop a low pressure system, for example. If there isn't one in the initial conditions, but there should be one developing within 24 hours, the AI models have gotten pretty good about causing one to build up and develop. But the farther you go in the future, and the more extreme the future, and the more absent it is in the initial conditions, the worse they often are. And in the extreme version, pop-up thunderstorms, that's a tricky one that has yet to be solved. So, just a little bit of scientific background. I think I'm going to wrap up this session soon. Again, I do anticipate further storms backbuilding down into San Diego area, down the coast. So if you haven't gotten it yet in this area, you're probably going to get some later. And if you're up here, you're probably mostly done for the evening. But I'll leave this up while I ask a couple more questions here. Still not seeing any fires popping up. All right, well, I've been talking a lot today, so I think I need to give my voice a break. But thanks again for joining the pop-up session. I do offer these occasionally, as you know, when the weather gets interesting, especially when it gets interesting unexpectedly. So this is a mix of the expected and the unexpected. And I don't foresee a huge fire outbreak nor a huge flood outbreak. This is more weather that is genuinely interesting and largely non-destructive. It's going to wreak havoc on the freeways. There could be some localized flooding or some localized fire ignitions, but I'm not seeing it as a hugely destructive harmful event. This is more of a gee whiz, this is pretty interesting thing. And for thunderstorm starved Southern California weather watchers, this is a bit of a treat. So if you're able to go out and watch it safely. The most dangerous thing about this is probably the lightning, which is dangerous no matter what the context. So keep in mind that just because it's Southern California does not mean you can't be struck by lightning. Good shelters are buildings with full roofs, not just canopies, and metal roofed vehicles. It is fairly safe if you're going to go sit out in a car of a metal roofed vehicle and stay inside the car. You're pretty safe even if lightning strikes nearby. So that's another way to get out there and take a look if you want. All right, I will talk to you next time when there will probably not be a thunderstorm outbreak in Southern California. So thanks for watching.